Hello, and welcome to Module 13.4, Triangle Sum Theorem. Our objective for today is that I can find the measure of interior angles in a triangle by using the Triangle Sum Theorem. So, first of all, what is a triangle? Let's define that. A triangle is formed by three line segments that intersect at their vertices, otherwise known as endpoints. All right, so if we look at our triangle that we have shown here, we can identify some different things. So you have three sides. One of them would be segment AB. You have BC, and you have CA. Now, each of those could be written in either order. So it could be segment AB or BA. It's still the segment that is connecting corner A with corner B. Our vertexes or vertices, we've got A, B, and C. And when it comes to our angles, we have angle A, angle B, and angle C, right? That little kind of half triangle thing, that is a symbol that we use to represent an angle. However, there's a second way to write all of these angles that you'll see sometimes, including later on in this unit. So angle A goes from here to here to here. So we could rewrite that as angle BAC or CAB, right? Angle B is going to be this angle here, so that could be written as angle ABC. So the inflection point, the vertex that you're of the angle is going to be the center letter that's identified. And then angle C, if we take a look at it, angle C is A to C to B, so we could say angle ACB. All right, so those are two different ways that we could represent these angles. Now, you'll see them identified by their letters when it could refer to more than one angle that is happening at that vertex. So if you had another, if instead we had another shape here where this could be like that, well, now angle A could be one of a couple different things. Is it this angle? Is it this angle? Is it this angle? So by naming them by letter, we're able to identify exactly which angle we're talking about when there could be more than one that's being referenced. All right, so let's talk about angle relationships. First of all, we have types of angles. An interior angle. These are going to be the three angles that lie inside a triangle. So A, B, and C, the three angles on the inside. Interior, inside. Pretty obvious there. Exterior angles, we're going just as obvious, but these are angles formed by one side of the triangle and the extension of the adjacent side. So you'll see it's this angle here, it's this angle here, and this angle here, where you've got this being an extension of the triangle, and here's the adjacent side for it, right? Here's the extension, here's the adjacent side. Here's the extension, here's the adjacent side. All right? Remote interior angles, we will tackle this more in our next lesson, but each angle or each exterior angle of a triangle has two remote interior angles that are not adjacent to the exterior angle. So if your exterior angle is that one, your interior angles are this and this. These are your two remote interior angles, okay? They are not touching the outside angle, the exterior angle, they're not touching it, but they are both within it. And we're going to talk about that property or those properties more in our next lesson. All right, so let's start by identifying the angles inside of this triangle or involving this triangle. So our interior angles, the ones that are on the inside, it's going to be the ones that are inside of it, obviously. So it's angle 2, angle 3, and angle 4. 2, 3, and 4 are interior angles. What is my exterior angle? It's the one on the outside, angle 1. And lastly, what are my remote interior angles, right? So here's the exterior. So these are my remote interior. So angle 3 and angle 4. Again, we will tackle that more in our next lesson. All right, triangle sum theorem. You may know this already, so bear with us. But if you don't, the sum of the measures of the interior angles of a triangle is 180 degrees. Okay, the sum of the measures of the interior angles of a triangle is 180 degrees. So in the model that we have off to the right here, we have x degrees plus y degrees plus z degrees is going to equal 180. All right, so let's find some missing angle measures using this property. So our three angles get added together, so 77 plus x plus 54 equals 180. So first thing we need to do, combine like terms. 77 plus 54 is 131 plus x is equal to 180. Then we subtract 131 from both sides, and we get that x is equal to 49 degrees. Make sure that you are including the degree symbol when appropriate. When you're actually getting a degree answer, make sure you have a degree symbol. All right, now, this one's a little bit different because we're given each of these angles as an expression that represents degrees, but not actually the degrees. But we're still going to take the same approach. We are going to add them all together. So I'm going to do 7x plus 6x plus 5 plus 4x plus 5 equals 180. Okay, so my first step is still to combine like terms. 7x plus 6x plus 4x is 17x. Plus 5 plus 5 is plus 10 equals 180. We're going to subtract 10 from both sides. 17x equals 170. And then divide by 17. X is going to equal 10. But does this answer the question that I asked at the beginning, which was, what are the degrees of these angles? I found what my x value is, but my x value is not the degrees. I need to take that 10 and substitute it into each of these expressions to find what each of these angles is going to be. So we start with our 7x. So 7 times 10 is 70 degrees. Okay, so that is that angle. My top angle, 6 times 10 plus 5. Well, 6 times 10 is 60, plus 5 is 65 degrees. And my third angle, we've got 4 times 10 plus 5 is 45 degrees. So our three answers, we've got 65, 70, and 45. And you could always double check your work here, because if you do 45 plus 65 plus 70, you get 180 degrees, so you know your answer is correct. All right, we're going to go on to our next page, please. At the top of the page, we have a box and we have a triangle. And so we're going to find our x value first, and then we need to find each of the independent angles. So Let's start off with our sum. We do x plus 4x plus 5x equals 180. Combine like terms. 1x plus 4x plus 5x is 10x is equal to 180. Divide by 10. X is 18. So we can fill that into our table, 18. Now, angle number A, or angle letter A, is going to be just our x value. So that is 18 degrees. Angle B is 4 times 18, which gets us 72 degrees. And angle C is 5 times 18, which is going to get us 90 degrees. So this one is the case where just because the picture looks a certain way doesn't mean that we can automatically trust that it's graphed or drawn the way it is. All right, because clearly none of those, that angle for letter C does not look anything like a right angle, but that's the way it comes out calculation wise. And again, we can double check our work and we can do 90 plus 72 plus 18, and we would find that we're going to have a value of 180 degrees. All right. So now we've got 3 problems down at the bottom. I want to encourage you to try these on your own and then check your work against mine. All right, so if we look at the first one, we've got 26, 115, and y. So if we set this up again, 26 plus 115 plus y equals 180. When we combine our like terms of 26 and 115, we're going to get what? 141 plus y equals 180. And then we subtract 141 from both sides, and we get y is equal to 39 degrees. So our angle for y is 39 degrees. All right, now let's look at our second one here. We have 3 expressions relating to x, so we're going to start off 12x plus 2 plus 26x plus 6x plus 2, and that's going to equal 180. And we lost kind of room there, but we're going to make it work. All right, first step, combine like terms, 12x, 26x, and 6x. When you add those 3 together, you get 44x plus. We have a plus 2 and a plus 2, so that's plus 4 equals 180. Now I need to subtract 4 from both sides. 44x equals 176. And then we divide by 44, and we get that x equals 4. So when we go ahead and substitute this into each of our corners, so 26 times 4 is 104 degrees. 12 times 4 is 48, plus 2 is 50 degrees. And our last one, 6 times 4 is 24, plus 2 is 26 degrees. Again, if you add these together, 104 plus 26 is 130, plus 50 is 180. We have our correct answers. All right, now, when we look at this one, we can do some deductive reasoning here. First of all, angle C, we already know, is 90 degrees. So we could do one of 2 things. We know that that's 90, so your other 2 angles have to add up to 90. Or if we're using Triangle Sum Theorem, all 3 angles add up to 180. Either way, you're going to reduce your work in a moment. So I'll do the full work, 7y minus 10 plus 3y plus 90. And we're going to move this down so we have a little more room. Plus 90 equals 180. So if you're using Triangle Sum Theorem, that's the work that you get. Now, combine like terms. 7y plus 3y is 10y. And 90 and negative 10 would be 80. And then we go ahead and subtract 80 from both sides, and this is where both works start to combine. And you get 10y is equal to 100, which when you divide, you get that y is 10. Now, you could have gone triangle sum theorem and then did some reasoning and said, well, okay, if we know one angle is 80 degree, or 90 degrees already, we can take that away and say 7y minus 10 plus 3y equals 90, right? We could have done that, and then when you combine like terms, you get 7y minus, not 7y, 10y minus 10 equals 90. You're going to get to the same point when you subtract 80 from both sides. You'll still get to 10y, or when you add 10 to both sides, you're going to still get to 10y equals 100. Divide by 10, and you get y is equal to 10. All right, so now angle A is 3 times y. 3 times 10 is 30 degrees. And angle B, 7 times 10 is 70, minus 10 is 60 degrees. So this is a 30, 60, 90 right triangle. All right. So that is the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.